and it could well become jammed by the effects of global warming.
In the North Atlantic, CO2 sink, which is very intense because of a lot of biological activity, appears to be now reducing and possibly, yes, saturating over some period. On land, we can talk about real saturation because the CO2 sink on land could stop if the fertilization by CO2 stops, and also it could even reverse and start putting its carbon to the atmosphere.
This could reduce the efficiency of the natural carbon cycle by 5 to 30%.
If the two sinks become weaker because of climate change, then the result will be that less CO2 will be absorbed by these two sinks, thus it will stay in the atmosphere and cause more warming. And the estimates at the moment is 0.1 to 1 and up to 1.5 degrees more warming by the end of this century.
During the 2003 heatwave, the process of photosynthesis was disturbed. A certain number of European forests actually started to reject more CO2 than they were absorbing, and thus became sources of CO2. Hence the idea to build this giant umbrella to exclude rainfalls and to study the consequences of a multiplication of droughts.
L'inquiétude, c'est si le climat change, c'est-à-dire si la température augmente et si les sécheresses deviennent de plus en plus importantes, les arbres vont absorber moins de CO2 de l'atmosphère. Donc, le CO2 dans l'atmosphère va augmenter, l'effet de serre va augmenter, le climat va changer de plus en plus. Donc c'est un cycle qu'on appelle un effet rétroactif.
To put it another way, the hotter it gets, the hotter it will continue to get. The only way out is to limit the increase of temperatures to 2 degrees Celsius to avoid becoming helpless in the face of climate change.
The 2 degree is a compromise. Now, the response of the Earth to global warming is in many ways gradual, but there are some important thresholds. And one of the most important thresholds is the degree at which the Greenland ice sheet will melt. And this, we think, is somewhere between 2 and 4 degrees globally. So 2 degrees actually gives a relatively fair chance that this is not exceeded. And there is about 5 to 7 meters of sea level stuck in the Greenland ice sheet, so that's very important.
At the foot of the Colorado Mountains, in a dark room of the NOAA, the American Oceanic and Atmospheric Administration, sits a strange machine, the carbon tracker. This machine allows us to visualize our carbon emissions for any given year, and what we see is staggering. Flames of CO2 actively consuming our planet.
The aim of Carbon Tracker is not to spy on governments or people. The aim is to help people and governments to reduce emissions. Because once the observing system is as good as we hope we can make it, we want to give objective feedback on what is working and what is not working. And I think ultimately we all need to know that. So here we are in the lab where we receive the samples from all over the world. For example, in these boxes are our airplane samples. And here you see boxes that have the samples that come from places really all over the world. So for example, this one comes from Lampedusa Island, a part of Italy. This box comes from Christmas Island, which is a small island in the middle of the Pacific Ocean.
These bottles of compressed air have been collected by weather stations, by planes or by ships. They allow us to quantify the level of greenhouse gases of more than 24,000 samples. The inventory does not cover the entire globe as yet, but it is continuously growing.
We expect that very soon we will be in a global regime whereby every country in the world is starting to make promises that they will be reducing emissions. And of course that is going to cost a lot of money. I mean, I'm talking trillions of dollars per year, enormous amounts, because we need to reform our entire energy system.
though he looks like an eternal student, Dimitris Angelis is in fact one of the most talented economists of his generation. He teaches at the prestigious London School of Economics and is one of the main authors of the Stern Report, named after the ex-vice president of the World Bank. The report estimates that the cost of global warming will reach $5,500 billion.
The main conclusion is simply this: the costs of action are dramatically lower than the costs of inaction, and the costs associated with delay are very, very high. Every year, every month that we do not act, the stock of greenhouse gases increases, and therefore the work we need to do to meet any temperature level in terms of emissions, that's the flow into greenhouse gases, goes up. You know, these gases sit in the atmosphere for 10, maybe hundreds of years. So every year that we put more, we actually have a harder work and a higher starting point to address this problem from.
In 2006, the Stern Report was a turning point for all concerned. For the very first time, global warming wasn't just a mere danger for the ecology of the planet, it was also threatening its economy.
At least over the next few decades, something like 1%, perhaps 2% of GDP would need to be devoted to addressing the most significant risks associated with climate change.
To put it another way, acting now against global warming would be 20 times less expensive than doing nothing.
Why is it so cheap? Well, a lot of the technologies already exist. By various estimates, we could do between a quarter and half of the reductions in emissions simply by taking steps to improve efficiency in energy generation and distribution, efficiency in consumption, efficiency in buildings, efficiency in transport.
No, we didn't come here to meet José Manuel Barroso, the media-friendly president of the European Commission, but Stavros Dimas, the European Environment Commissioner. Since 2004, Stavros Dimas has been in charge of the difficult program on European reduction of emissions of carbon dioxide. A challenging task indeed for a man who decided that Europe would set the example for the rest of the world.
The European Union has taken the leadership in fighting climate change. We exercised a lot of pressure and a lot of efforts in order to put in force the Kyoto Protocol.
Kyoto was a first step taken in the land of the rising sun. In December 1997, 141 countries promised to sign the Kyoto Protocol, with the notable exception of the United States. They committed themselves to a reduction of 5.2% of worldwide carbon dioxide emissions based on the 1990 figures. A reasonable objective, which Europe was soon to overtake.
The European Union has a collective target of reducing by 8% its greenhouse emissions. And we are on the way to achieving this target. And by the year 2012, which is the deadline, we are going to overshoot this target.
Not everyone decided to follow Europe in its wish to be top of the class. Eric Schäfer is a renegade. In 2004, the former director of the National Agency for the Protection of the Environment in the United States slammed the door and left the agency.
They're very friendly to the coal and oil industry, and the lobbyists in Washington went to the White House behind me and said, you need to get the EPA to stop doing what they're doing. And eventually the White House told us, you need to pull back.
So you decide to quit?
Yeah, what can you do? You're supposed to enforce the law. You're not allowed to enforce the law. I left.
Now director of the Environment Integrity Project, Eric Schäfer keeps bringing lawsuits against the big companies in the energy sector. One of his favorite targets is the Morgantown coal power plant on the banks of the Potomac River.